problem says, given that theta is in between 0 and 360 degrees, and cosine theta cosine 350 plus sine theta cosine 100 equals root 3 over 2, solve for theta, give our answer in degrees. There are two answers. So this should strike you as resembling very much the identity for cosine of a double angle. So for example, cosine of A minus B happens to be cosine A cosine B plus sine A sine B. So this looks very close to that because you got theta playing the role of the A. The problem is these two angles are different. And not only that, actually, this says cosine and it's supposed to say sine, right? But it says cosine of a 100. But on the left side, the 350s, looks like it's playing the role of the B. So something tells me there's got to be a relationship. There's got to be a relationship between cosine of 100 and sine of 350. Like we want that to be sine of 350 there. So let's go sketch it. I bet you there is a relationship. So cosine of 350 degrees and cosine of 100 degrees. So if I go sketch cosine of 100 degrees, that's like rotating 90 plus an extra 10. Okay, so then this angle here must be 80 degrees. And again, let's make sure, let's say I'm on the unit circle. That's 10 degrees. All right, now, so then cosine would be, the cosine of 100 degrees would be this value here, that x coordinate. Whereas cosine of 350 would be, again, it'd be this rotation, except the last 10. Something like, looks something like this. So like that's 10 degrees. And if we fill out this triangle, again, the unit circle will say that's a 1, 80 degrees. Now look, these triangles are congruent. So the side opposite the 10 degree, I could also label x. Notice I didn't name it negative x because in both diagrams, they're both negative, right? So whatever that x value is, they're negative. But so the thing to notice here is like this here, that is the sine of 350 degrees, right? We rotated 350 degrees, that's its y coordinate. And this is the cosine of 100 degrees, and we see that they're equal. So we see that cosine of 100 degrees is equal to sine of 350, and so up here, I can just replace that with sine of 350. And now I just want to point out what we have. We've got, now it says cosine theta cosine 350 plus sine theta sine 350 is equal to root 3 over 2. Okay, and now I'm gonna kind of use the formula in reverse. This is the cosine of theta minus 350. Okay, again, remember it's an angle difference here. Just using it in reverse. Okay, so that was actually a little bit of work and we're still not done. But I do recognize root 3 over 2 as a special angle. So let's call this thing W for a minute. Let's see if we can figure out what kind of angles have a cosine of root 3 over 2, and then we'll just make this little theta minus 350 adjustment when we need to. So off to the side, let's just recall what we're doing. That's that. Now, over here, let's decide where is cosine equal to root 3 over 2. Well, that happens in quadrant 1, and so it would happen at 30 degrees, right? Okay, that's a half. This is root 3 over 2, so it happens at 30 degrees. And then it also happens at negative 30 degrees, or any angle coterminal with that. So I'll just put that reference angle in. That would be negative a half. Of course, that's a 1. Okay, so now I know this W. Let's see what kind of angles. Theta is only supposed to be an angle between 0 and 360. But look in our diagram. W can be 300 degrees, so let's start there. So if W is 300 degrees, the cosine of if W is 30 degrees, the cosine of 30 is root 3 over 2 from our diagram. So W could be 30 degrees, which would mean that theta minus 350 is equal to 30 degrees. If you add 350 to both sides, you get 380 degrees is equal to theta. Now, that won't work because we need theta to be between 0 and 360, so we need to find a coterminal angle. So just minus 360, and we get that theta is 20 degrees. So that's one answer. They said there were two. And the second one's going to come from this quadrant. So we also can see, for example, actually, why don't we use negative 30 in this diagram? That'll be fine because we're putting it in for W. So W could be negative 30 as well. So I'll write that here. W could be negative 30. But if it's negative 30, that would be theta minus 350 from our identity above here. And if I add 350 to both sides, I get 320 degrees is equal to theta. And that should be my, my second answer. So the two angles are 20 and 320 degrees. That was actually a pretty challenging problem, I would say, because it had like two steps. So it's a good one, but it's not trivial.